Hello everyone, welcome back for the session on AIML where we're going to learn everything in order to become like a successful data scientist. So yeah guys, hope you guys are enjoying this session. We have come to a stage where we're going to reach, I think this is a second module introduction, we're going to reach the final step. Okay, so because like we have gone through a basics, what the data, how we need to clean the data, how we go for visualization, like those things, and then some coding, Python and R coding we have just gone through, and we have jumped into machine learning, okay, where we discussed about supervised, unsupervised. Within that we have discussed about lots of algorithm. Today we're going to see model evaluation and like validation techniques, okay, because like once we build a model, we doesn't know, if we doesn't know how to treat the model, whether it is giving a good result or bad result, then what to do. Okay, so that's the reason guys, so that's a major thing that we're going to do today. We're going to see model evaluation and validation techniques. Okay guys, I will 100% sure if you guys are straightly watching this video, you guys doesn't gonna have anything about it. Okay, you guys doesn't gonna understand nothing from it. Okay, please watch previous session video so that you can have a better understanding of what we are telling now. Okay, so please guys, I just ask you guys to watch all the previous videos so that you can have a like a flow and also understanding of what we are talking today. Okay, so guys, today is all about model evaluation and validation techniques. It's gonna be a theoretical part, but hope once we are going for a coding session, it will be very easier for you to understand what it is happening in the background. Okay, this is what for that. Okay, so model evaluation and validation technique. So evaluating machine learning models is crucial for ensuring their performance and reliability. This involves accessing their ability to generalize to unseen data and making accurate prediction. So this presentation explores key techniques for evaluating and validating machine learning models. Okay, yeah, that's true. We are training our model, we are trained our model is ready, and we are just testing our model. Okay, and going for the prediction, like see guys, whenever it comes for unseen data, even though we train our model for 100%, we should not say 100%. Okay, everything is probability is not going to be 100% for machine learning model, somehow nearer to 95 consider. But it is not the same case for the unseen data. There will be some kind of loss from the 95. Okay, that is what the validation we need to make, how to fix it, what kind of techniques we need to use in order to fix it, what are the different stages that we are having. So that all thing we're gonna see today. So I'm very excited to talk about this topic. So yeah, I hope you guys also. So yeah, sir, over to you.
Yes, so model evaluation and validation techniques, guys, we need to understand uh, how, like machine learning models, they are very crucial. Like, so how they do that, what are the concepts? You need to understand deeply the conceptual part, don'ts and do's and don'ts, and also limitations, so that then only you can be like you can use it, okay, properly. So they are very crucial for the performance, ensuring the performance, reliability, and it also involves the ability to generalize. Okay, you will not have 100% accuracy, as Raja already mentioned. It is, you will have 95 plus, like 90, 95 plus is a good accuracy. You will never have 100 plus. So reliability, the performance and reliability is very important when you, okay, for model evaluation and validations, whatever techniques we use. And it also helps us presenting, exploring techniques, okay, evaluating, validating machine learning models. So we'll go into this session, we'll understand model evaluation and validation techniques, their limitations, do's and don'ts, where we can use them, where we can't, and everything about it. And we'll go deeper at a meta level for these models, model evaluation and validation techniques. Thank you. Let's move to the other slide.
Yeah, sure, sir. So moving on. Okay, train and test split. Okay. Train and test split is a fundamental technique for evaluating model performance. The data is divided into two sets: a training set for model training and a test set for evaluating the model performance on a unseen data. Training sets use it to train the machine learning model. Test set use it to evaluate the trained model's performance on unseen data. Okay, I will put it in this manner, guys. This is a simple concept: train and test split. Okay, consider we are having 100 data. Okay, if we provide all the 100 data to the model and we train it and we are just asking questions from the 100, it's gonna be saying everything right. It's true, right? Okay, I will put it in a simple manner. As a human being, okay, we gonna get the question paper, okay, and we are having all the questions, okay. Consider we are having only 10 questions that are given to you. If the 10 questions gonna be come, same 10 questions gonna be coming in the exam, means we all gonna get 100, okay. If something gonna come out of the box like 11th question, then we doesn't know anything. So same way, that's the reason what we need to do means we need to split our data. Whenever we are having 10 data, we need to split, okay. We just need to give only 6 data to the model, or 6 data, 6 paper to the for the students. They get generalized with the concept instead of mugging up or memorizing. They get generalized with the concept, and whatever the questions will be in the exam, they can easy to able to answer it, okay, because they have generalized it instead of memorizing it. They have generalized it, so now they know out of the box also, okay. Based on the concept they have learned, they can applying the same thing to the model, okay. We are having train test split, right? While training, we are just giving 6 data so that the model can learn from it and make generalization, okay. Now the model is trained. Now I'm gonna give the data which is not seen by the model, but model can predict because it has generalized the 6 data which has the features of the 4 testing data that we're gonna test, okay. So hope you guys have understand this, because like we doesn't need to give all the data for training and then choosing data and then testing, because it is a form of memorizing, making the model memorizing. Instead of making the model memorize, we need to generalize our model so that it can tackle all the data in the form of the data which is present in the training, okay. So hope you guys have understand this. Yes sir, over to you.
Yes. So training is very, very important. So we train, test, and split. So this is what we do. So whenever we are evaluating model or selecting model, or what you say is, we're training. Okay. So we have to, once we select the model, then we have to start training on the uh, data. Whatever data we have cleaned, pre-processed, we have done EDA stuff, all the previous steps. So go and watch all the sessions, guys, 5 to 10 times. Then and only come to here, because it will go above your head. What we are talking training, so training data. So we, like you guys, if you're new to this, so you might have heard training people, but how to train data? So it will go above your head here. So watch all the sessions 5 to 10 times. Do reinforce learning, absorb, digest, and implement the information and apply. Do all the application, all the assignments, and then and only come here, because otherwise it will go above your head. So training so train, test, split is a fundamental technique for evaluating model performance, guys. Because if you have done everything, you have collected, cleaned, pre-processed, EDA, ensemble, learning, everything you have done. But if you are not going to train, nothing will come out. If you are not going to test, nothing will come out. You so you have to do this now, okay? So data is divided into two sets: training set for the model training, and test set evaluating the model performance on unseen data. Okay, you have to training, splitting, and test. Train, test, and split. That is very important, because you have to split it for test and train. Okay, training set is used to train machine learning model. Training set is simple. You train the machine learning model based on training data. Test set is used for evaluating the model performance on unseen data. So this is how we evaluate, we pick the model, and then we do training, test, and split. So this is what we do after we pick the model on the data which is collected, pre-processed, cleaned, collected, cleaned, pre-processed, and EDA and all those things done, so that it is ready for model. Then you choose the model, then you do train, test, and split. Let's move to the other slide. Thanks.
Yeah, sure sir. Okay, yes. Moving on, we are having a next thing. Like we have now discussed about train test split. Now cross validation, guys. So cross validation is a robust technique that involves dividing the data into multiple folds and training and evaluating the models on different combination of folds. This helps to estimate the model generalization performing more accurately. Okay. The thing is, this is somewhat similar to train test, but what happens here means all the data will be belongs to the training as well as testing. So what happens means now the model will generalize everything and will learn all the data. I hope like this is somewhat confusing. Let us put it in a simple manner. Okay. First is k-fold cross validation. Data is divided into k-folds. The model is trained on k minus 1 fold and tested on the remaining fold. Okay, I will put it in a simple manner. Now we are having 10 data. Okay. Now I'm gonna train my model with 9 data and I will keep one for testing. Okay. First, start with the k fold like 9 is to 1. Okay. First 9 data for training and 1 for testing. Then for the second step, first 1 data is for testing and then the remaining 9 data for training. Next, what happens means first consider first step, first data number 1 for testing, other for training. Second stage, second data is for testing, other things are for training. Third stage, third data is for testing, other for training. So what happens means all the data will be considered for training as well as testing. Now the model gets generalized and it know all the data. Okay. Now let us come to this step. Leave one out cross validation method. Okay. It's a special case where each fold contains only one data point. The model is trained on all data points except one and tested on the left one output. Okay, this is leave one out cross validation case. Okay, so k-fold can be anything, but this leave one out is only one data. The same process, k-fold we can have something like 6 data for training, 4 for testing, and the next step we will be having 6 other data for training and another 4 for testing. Like there is a combination of 6 4 6 4. Whereas in leave one out cross validation, what happens means one data for testing, other for training. Next time, other one data for testing, other things for training, like that. Okay. What we are doing here means we are making all the data in our data set for training as well as testing so that our model makes generalized things. Okay. So hope you guys have understand this. K-fold means K means number of items that we're gonna have in testing. Okay. 10 data, 6 for training, 4 for testing, first 6 for training and then 4 for testing. Next stage we will do alternative like some type of permutation combination, first 4 for testing and then 6 for training, like that we will change. Whereas in leave one out cross validation we are having 10 data, first one for testing, other for training. Second stage, last for testing, last one for testing and other things are for training, like that we will just do permutation combination here. Okay, hope I have explained in a manner. So I think sir will explain in better manner. Okay, yes sir, over to you.
Yes. So rightly explained. I'll make it little simpler and you'll understand it. See, cross validation is, guys, simple. If you again go to the basics. So whenever you are in doubt, go to the basics. Name will suggest something. Everything suggests something. So cross validation. We do cross validation, right? We validate here, we validate there. This is what is called cross validation, right? Suppose you will go to market. You want to buy a pair of t-shirts. So you like two brands. Suppose you like Nike, you like Reebok, you like Adidas. So you'll visit those three stores and then you will validate on what? You will validate on price, you will validate on quality, you will validate on color and your choice and the size. Similarly, here cross validation will happen based on data. There is also data because you are just doing physically, you will not, maybe you will not feel that way, but that is data also. Here model will do the same thing in a different, but here data is huge. Okay, so cross validation is a robust technique which involves data into multiple folds. There would be multiple folds that you need to understand, training and evaluating. Okay, and different combination of fold, there will be different combinations. Okay, and it helps to estimate models generalization performance for more accuracy. accurately predicting. Like that is what we have to do. So k-fold cross validation is data is divided into k-folds. So suppose in clustering, we made groups. Okay, here we will do the same thing. We divide data into k folds. Just understand, making separate k fold. That is what is k. The model is trained on k minus 1 fold and tested on remaining data folds. So suppose 60% data, whatever data is there, you've just trained your data, and 40% you are tested, right? 60/40, you can do that. So k minus 1 means that. So it's, if you just understand simply, this is like 60% train and 40% test. Okay, then leave one out cross validation is a special case where each fold contains only one data point. The model is trained on all the data point except one tested, okay, on the left out point here. So leave one out cross validation is different, like it is opposite. It will not test the k fold where we already done the testing, but it will do on the remaining 60%, guys. 40% we have done the k minus 1, right? We did the test. So we have done that. So here the special case is that the each fold contains only the data points. The model will train on the all data point except the tested one. When we did k-fold cross validation, we had only tested data 40%. Here it will do not do that, but to the remaining, which like we use for training. So that is the difference between level 1 out cross validation and k-fold cross validation. I hope it is clear, so that you understand there's a differentiation, and these two different validation uh, techniques will help us to validate the data, okay, for the model. Thanks.
Yeah, actually, that's great, sir. So, sir has explained in a simple manner by using the name sir is explaining. Okay, great, sir. So, yeah, this is what about cross validation we are having. So, moving on, we're going to see the next thing. Okay, let's see what we are having. Go next. Okay, overfitting and underfitting problem. I think we guys have explained this. Okay, no problem. We will explain again because like it's one of the evaluation technique. So overfitting and underfitting. Overfitting occurs when a model learns the training data too well, leading to the poor performance on the unseen data. Underfitting occurs when a model fails to capture the underlying pattern in the data, resulting in low performance on both training and testing data. Okay, I hope this is easier for you to understand. Okay, now just divide it. I divide it. Okay, overfitting model memorize the data, training data, leading to the poor generalization. Underfitting model is too simple and fails to capture patterns in the data. Okay, ideal model should be models strikes a balance between fitting the training data and generalize well to the unseen data. Okay, I will put it in a simple manner, guys. Okay, we are let's put very simple manner. What is meant by overfitting? We are training our model on the training data and it gives 100% accuracy. Now what happens means the model has memorized all the data, so that's the reason it is giving 100% accuracy. Now if you go and test the model, it will work poor for the unseen data. Okay, because it has 100% accuracy, it has memorized all the data that we have given for the training. That is what overfitting. Okay, what is meant by underfitting? We are training our model and our model doesn't work for the training data itself, then it is underfitting. Now there is a point, no point of testing data because our model doesn't work for the training data itself. So if the model doesn't work for the training data as well as testing data, then it becomes underfitting. Okay, hope you guys have understand this. Overfitting means the model works 100% for the training data which fails to generalize the test data. Underfitting means the model doesn't work for the training data, so there is no point of going for the test data. Okay, now how an ideal model should be? Ideal model should balance this fitting, that is, it should train on a training data and should able to generalize well for the unseen data. Okay, guys, this I don't see any interviews without this question, overfitting, underfitting. Very, very important question. Try to understand the base of it so that you guys can build on top of it. That's the thing, guys. Okay, so try to understand it. If you guys have any doubt, just ping in the comments. We are here to help you. Okay, so yeah, sir, over to you.
Yeah. So overfitting and underfitting is a very, very, very important technique, guys. We have to understand it. So it occurs only when model learns. See, overfitting, it occurs only when model learns the training data too well. Like it will happen, overfitting, okay? And leads to poor performance on the unseen data. Because there is no space now to learn more. That is why overfitting happens. Because for unseen data, you have to learn that also, and that is why it happens. Okay? Then underfitting is a simple technique. It helps us to understand occurs when the model fails to capture the underlying pattern in the data, resulting lower performance both training and test. So that is what it will not do that. That is why it is used. Underfitting is it will not capture those underlying patterns and both training and test data. So that is the simplest way to learn about overfitting and underfitting. This is the simplest explanation. Overfitting model memorize the training data leading to poor generalization. That is what it is. Okay. Then underfitting, again, it is explained model too simple. The model is too simple. In a simple manner, you need to remember this. Fails to capture patterns in the data. On training and test. That's what it is. And ideal model is model strikes a balance between fitting and training data, generalizes well to unseen data. That is the ideal model. So we need to know what is overfitting, what is underfitting, and then we'll have a model which is ideal, so that it will give us better performance. It will generalize well. On the unseen data. That is why. See, guys, whatever is seen data will also get the insights. The main thing to main work of a model or an algorithm or a machine learning or deep learning is to get the insight from the unseen data. And when that is not done, then what is the use of a model? So underfitting, overfitting does not help in unseen data, okay, to get the insights. So ideal model is best model is when we will generalize too well unseen data properly on training and test. So we can see on a training data, because that is the most important thing on unseen data. So we generalize well, and so that the performance of the model will be good. We'll have right insights, guys. And once we have right insights, then we'll make right decisions. Model will make right decisions. We'll make right decisions. Data scientist will make right decision. He will communicate right insights. The management will make right decisions. Business will grow, and model will be good. Otherwise, if it is biased because of that overfitting, underfitting, something, right, is happening, it is not generalizing properly, it is not capturing the patterns data properly, will not build right model, it will not give us right performance, business will fail, model will fail, and the question will come to a data scientist that what kind of insights you have given. So that is why these terms, these concept techniques are very, very important. Understand them well. Let's move to the other section.
Yeah, sure, sir. So guys, yeah, this thing or we are having. So we have jumped into a important concept of evaluating our model. So we have looked into test, train test split, and then cross validation. Now we have seen about overfitting and underfitting. Guys, make sure that you guys have a proper understanding of this, because like whenever you are just building a model, right, it not ends building a model. As sir is mentioning, what is the point of building a model? It should predict the unseen data, right? That's the reason these things are very, very important. Hope you guys have enjoyed and understand all the concept conceptually, okay? Because like we're gonna do a depth-wise search, okay? This is just a depth-wise search. We're gonna do the depth-wise search. So this is what all about we are having for this session. Hope you guys have enjoyed this session. We're gonna continue this session for the next one. So hope you guys have enjoyed everything. We will all meet in the next session. Thank you guys. Till that, make sure that you guys have a perfect understanding. If you guys have any doubt, just ping in the comment. We are here to help you. Okay. Bye guys. See you all in the next session.
Yeah. So keep learning, do reinforced learning, go watch all the sessions properly 5 to 10 times and write in the comment section what have you learned, how what is your objective function, why you're learning these sessions, and have a long-term objective function and become a lifelong learner. Learn all these sessions, absorb, digest, and apply. Do all the assignments. First watch all the previous sessions, then come to this session, and let us move to the others session. See you. Thanks.
Yeah, guys. Bye. Take care. Bye.